In this video, we'll review fractions and we'll compute operations with fractions. So let's remember that a fraction is of the form a over b, where a it's called numerator and b it's called denominator, and the actual operation between a over b is a divided by b. So if we want 1 divided by 2, we can write it 1 over 2. So let's simplify fractions. So the fraction that we start with is 20 over 25. So both of these numbers can be divided by 5. So I'm going to divide by 5. And we get 20 divided by 5, it's 4. 5 divided by 5, it's 5. So 4 over 5, because none of these numbers can be, don't have any common factors. So in other words, the greatest common factor of 20 and 25, it's actually 5. The highest number that divides 20 and 25 evenly, it's 5. Because 1 also divides both of them evenly, but the highest one, it's 5. Now let's take a look at 45 over 30. So again, we can look at the and try to find the greatest common factor, but we can go also step by step. We notice that both of these numbers can be divided by 5 since they end up in 5 and 0. So 45 divided by 5, it's 9, and 30 divided by 5, it's 6. But we also notice that both of them can be divided by 3, so we get 3 over 2. And that is the fraction simplified. So in this case, if I'm looking for greatest common factor of 45 and 30, the actual value is 15. Both of these numbers can be divided evenly by 15. So the problem could have been solved this way as well. So I'm trying to solve the problem in a different method by dividing both of these numbers by 15, and we could have gotten 3 over 2 right away. So sometimes we can figure out the greatest common factor, the highest number that can divide these numbers evenly, or we can do step by step like I did when I divided by 5 and then by 3. Now let's take a look at 100 over 200. So we notice that both numbers can be divided by 100 evenly, so we get 1 over 2, final answer. Now if you don't see it and you divide by 2, you get 50 over 100, and you can divide by 5 and so on. You can do step by step. But if you can figure out the greatest common factor right away, which for 100 and 200 it's actually 100, then you can simplify pretty quickly the fractions. Now let's do a few problems where we multiply fractions. Well, the rule for multiplying two fractions, so a over b times c over d, well, we multiply across. That's how the rule is. So we multiply a times c over b times d. So that's what we get here. So in this case, for first example, 1 over 2 times 1 over 4 is we multiply across like the rule says. So we have 1 times 1, it's 1 over 2 times 4, it's 8. And this is the final answer. Sometimes we can simplify further, but not in this case. Now let's take a look at the next problem. 7 over 10 times 15 over 14. So I'm going to solve it using two methods. One method is to multiply across, so 7 times 15 over 10 times 14. And we can say, well, 7 times 15, it's 105, and 10 times 14, it's 140. And then we notice that we can simplify further by dividing both numbers by 5. So we get 21 over 28, and both of them can be divided by 7, and we get 3 over 4, final answer. Or I could have divided 105 and 140 by 35 right away. But another method that we can use is, well, let's remember again that this line means division, right? So we can take a look at 15 and 10. So I have 15 divided by 10. Well, both numbers can be divided by 5, and we get 3 here and 2 here. And then 7 and 14 both can be divided by 7, and we get 1 and 2. And so now when we multiply across what is left, 1 times 3 and 2 times 2, we get 3 over 4. So we get the same answer. So sometimes it's even better to multiply them like that, looking for common factors and simplifying them. Let's take a look at other problems where we still multiply, but the numbers look a little bit different. So for example, if I have just 2, right? Well, I'm going to write it 2 over 1 and then 1 over 2. So when we multiply across, we can say 2 over 2, which is 1, but we could also have said, well, 2 divided by 2, it's 1. So now when we multiply across, we get 1 over 1, which is 1. And then let's take a look at the next problem. 2 over 13 times 13 over 2. Well, 13 divided by 13, it's 1. And then 2 divided by 2, it's 1. So we get 1 over 1, which actually means 1. So when you see a number like 10 or 15 or -7, they actually mean over 1. We don't usually write the denominator as 1, but sometimes, like in this problem, in example 3, we had to write it so that we can easily see that 2, it's at the numerator in this case, and here it's at the denominator, which makes a difference. And now let's do a couple division problems. So when we have to divide A over B divided by C over D, we keep the first fraction, A over B. We change the division into a multiplication, and we flip the second fraction. So you see how here it was C over D. Once we times it, we put D over C. And then we multiply across. A times D over B times C. So let's do that. We have 1 over 2 divided by 3. Let's put 3 over 1. So let's write 1 over 2 times, and then we flip 3 over 1 into 1 over 3. And now we multiply across, so we get 1 over 6. Let's take a look at the second problem. 8 over 5 divided by 3 over 10. So 8 over 5 times 10 over 3. And then 10 divided by 5, or 10 and 5 can be both divided by 5, and we get 2 here and 1 here. So when we multiply across, we get 16 over 3. Now that we learned how to multiply and divide fractions, let's talk about adding and subtracting fractions. So there are two situations. The first situation is when we have the same denominator, so A over B plus or minus, depending on the problem, C over B. So B is the denominator, and it's the same for both fractions. Well, when that happens, we copy the denominator and we add or subtract the numerators. So for example, 2 over 5 plus 3 over 5, we copy the common denominator, and then we add the numerators, 2 plus 3. So we get 5 over 5, which can be simplified further, and we get 1. And we can have another example. We can have 3 over 7 minus 5 over 7. Well, we do have the same denominator, so we copy the denominator, and 3 minus 5, it's at the numerator. Well, 3 minus 5 is -2, so we get -2 over 7. We have different denominators, like A over B plus or minus C over D, right? Different denominators. Well, the key here is to find LCD. Now, how do we find LCD? Well, we write the prime factorization of each number, and then we multiply all the factors to the highest power. And I will show you what I mean by that. So let's try to do a problem like that with the numbers that we have in example 7. So 5 over 12 plus 3 over 4 minus 1 over 2. As we can see, we have different denominators. We have 12, 4, and 2. So the LCD of 12, 4, and 2 is what? Well, write the prime factorization of each number. So 12 can be divided by 2 and we get 2 times 6. 6 can be divided by 2 and we get 2 times 3. So the prime factorization of 12 is 2 times 2 times 3. So it's 2 to the second times 3. 4, it's 2 times 2, so it's 2 second. And 2, well, is just 2 to the first. So now write the prime factorization of each number. We did that. And now multiply all the factors to the highest power. So 2, it's a factor, but here is 2 to the first, 2 to the second, 2 to the second. So 2 to the second is to the highest power. And then times another factor, it's 3. So when we multiply this, we get 12. So the LCD of our example or our fractions is 12. So let's write here 5 over 12 plus 3 over 4, I'm going to leave a little bit room, minus 1 over 2, and I'm going to leave a little bit of room. So how do I get from denominator 4 to 12? Well, by multiplying the second fraction by 3 over 3, right? Why do I multiply by 3 over 3? Because 3 over 3 is 1, and 1 times 3 over 4 is 3 over 4. So in other words, I'm not changing mathematically or the quantity that we had initially. So 3 over 4 or 9 over 12 are equivalent fractions. Okay, taking a look at the third fraction, 1 over 2. How do I get 12 at the denominator? Is by multiplying by the fraction 6 over 6, because 6 over 6 it's 1, so I'm not changing again the fraction 1/2. I'm just writing an equivalent one. So now we get 5 over 12 plus, how do we multiply two fractions? Well, we learn how to do that, so it's 9 over 12 minus, how do we multiply these two fractions? We multiply across 6 over 12. So now, because we have the common denominator, or the denominator is common, it's 12, I'm just going to write at the numerator 5 plus 9 minus 6. And we get 5 plus 9, it's 14, minus 6, it's 8. So 8 over 12. If we divide both of them by 4, we get 2 over 3, final answer in the simplest form. Let's try example 8. 2 over 3 plus 1 over 2 plus 5 over 6. So again, we take a look at the denominators. We have different denominators, so we should start with LCD. So the LCD of 3, 2, and 6, what number divides evenly by these numbers? Well, 3, it's just 3. 2 is just 2. 6 is 2 times 3. So the LCD is copy all the factors to the highest power. So it's actually just 2 times 3, it's 6. And yes, 6 is the lowest number that can be divided evenly by 3, 2, and 6. So how do we get, now we want each of these fractions to have denominator 6, right? The third one already has. But the first one, we need to multiply by 2 over 2, because 2 times 3, it's 6. The second one, we have to multiply by 3 over 3, and the last one, we leave it that way. So now, 2 over 3 times 2 over 2 is 4 over 6, plus the second one, 1 times 3, it's 3 over 6, and the last one, it's 5 over 6. So, common factor 6, common denominator 6, and then the numerator is 4 plus 3 plus 5, so that is 12 over 6, but 12 divided by 6, it's 2, so this is final answer. All right, now sometimes the answers have the numerator larger than the denominator. So what do we do then? Well, if for example we have a number like 3 over 2, if we divide 3 by 2, we go 2 goes into 3 one time, 1 times 2 is 2, and when we subtract we get 1. So in other words, we get a quotient and we get a remainder. How do we write that? Well, we write it as 1 and 1/2, not times, 1 and 1/2. The first one is the quotient, and then the second one is the remainder. Now, going from this format to this format is by division, and this is called mixed number. While going from the mixed number to this fraction is using the formula below, and this is called improper fraction. Now, how do I go from a mixed number to an improper fraction? It's written here. So A and B over C, we are actually multiplying A times C, and we are adding with B, and we write over C. Now, why is this happening? Well, A and B over C actually means A plus B over C. So if I put A over 1 and I multiply by C over C, we are getting AC plus B over C. So this is the reason why the mixed number is transformed into an improper fraction using AC plus B over C, because we are actually adding a whole number with a fraction. So let's take a look at example 9. We have 4 and 3/5 minus 2 and 1/4. So I'm going to change this into an improper fraction by doing 4 times 5 plus 3 over 5 minus, let's do the same with this one, 2 times 4 plus 1 over 4. So 4 times 5, 20 plus 3, 23 over 5 minus 2 times 4, 8 plus 1, 9 over 4. So we have a subtraction between two fractions with different denominators, LCD of 5 and 4. Well, because they don't have any common factors, it's just 5 times 4, which is 20. So how do I get to 20 from here? We multiply by 4 over 4. How do I get to 20 from here? We multiply by 5 over 5. So 23 times 4, that's 92. Minus 9 times 5, 45, over the common denominator is 20. So 92 minus 45, that is 47 over 20. So 47 divided by 20, well, 20 goes into 47 two times, right? 2 times 20, it's 40, and there is a 7 left. So 2 and 7 over 20 is the final answer. Because we start with mixed numbers, our final answer should be a mixed number. All right, and a couple more problems. So let's have 7 and 1/2. So if we change that into an mixed number, into an improper fraction, we have 2 times 2 plus 1 over 2 divided by 3 over 1. So 2 times 7, it's 14, plus 1, it's 15 over 2, times 1/3. So how do we multiply? Well, we multiply across, or we can say 15 divided by 3, it's 5. 5 times 1, it's 5 over 2. But because the problem started with mixed numbers, then let's do that. 2 goes into 5 two times, and 1 is left, right? Because 2 times 2 is 4, 5 minus 4 it's 1. And complex fractions, it's another concept where we have a fraction, but then at the numerator we have another fraction, and at the denominator we have another fraction. So we have fractions over fractions. How do we deal with this? Well, what it means, this means division, so we can write it 1/2 divided by 3/4, and right away, by changing it like that, we made it a simple division problem, right? So if we change them and we use this line as a division, then we have 1/2 times 4 over 3. Now 4 divided by 2 is 2. So when we multiply across, we get 2 over 3, final answer. So complex fractions can be changed by doing numerator divided by denominator, and it becomes a simple division problem between two fractions.